What's up, everybody? This is Danny Mathematics here with another example to explore. And today, guys, I want to go over example 1 of how to find out the domain and the range of a graphed function, okay? And remember, guys, the domain is the horizontal boundary along the x-axis, right? So how far can the function actually expand horizontally, okay? That's the domain. The range is the vertical boundary of the function, right? How high and how low in depth can the function expand vertically, okay? That is the range. So once again, the domain is the horizontal boundary of the function, and the range is the vertical boundary of the function, okay? So let's go ahead and look at this. So let's go ahead and start off with the domain, right? And remember, guys, domain is horizontal, all right? So if it's horizontal, that means that we're trying to figure out what is the boundary, right, along the x-axis. So that's why I'm putting these horizontal arrows, right? Because we're going along the x-axis. So that's why I have x right here, okay? So now I'm going to start from the least side, right? Going from the left, coming from the left. So as I move my vertical line test over, guys, I notice, guys, that the lowest x value that x could possibly be is at x equals -1. So that's why I'm going to put this green line, right? That will show you that, okay? So as you notice, guys, the lowest that x could be that's a part of this function is at -1, right? And x can be -1 because this particular dot is actually shaded in. It's actually shaded in, which means that x could actually be -1. So here's what it's actually saying, guys. It's saying that x is, because x could also be all these other values too that are greater than 1. Greater than -1, my bad, greater than -1. So what it's saying, guys, is x is greater than or equal to -1. Greater than or equal to -1. It could equal -1, that's why it has a shaded in dot, but it also could be these particular values that are greater than -1, okay? Now, what I'm gonna do is I'm gonna find out what is the greatest x value that x could be. What is the greatest x that x could actually be, right? And I stop at x equals 4, or 4, right? Along the x-axis. So I'm gonna draw this little boundary right here. Okay, so if you notice, guys, the highest x could possibly be is close to 4. But if you notice, this particular dot is unfilled. It's not shaded in. So that means that x can only be less than 4. It cannot equal 4. It could be 3.99999, right? But it cannot actually be 4, right? So it's saying that x can be any of these particular values that are greater than or equal to -1 and less than 4. So all of these particular values, right, are either -1 or greater than -1, but all are less than 4. So that's going to be the domain of x. That's the horizontal boundary of the function, all right? Now, let's go ahead and do range. In the range, that's why I'm putting a vertical arrow going up and down. That is the vertical boundary of the function, all right? So we're going to start off by trying to find out what is the lowest value that y could possibly be, right? And because this function don't have arrows, right, it's not continuous, okay? So as I move up and I stop right here at the lowest point, the lowest y value that y could possibly be is -4. As you can see, the lowest y that y could possibly be is -4. And that particular dot is actually shaded in, so y can actually be -4. So what it's saying is y is greater than or equal to -4. It's either greater than or equal to -4. So it could actually be -4 or any of these particular values that are greater than -4, all right? Now we're gonna find out what is the highest value that y could possibly be. What is the highest point of the function? The highest point looks like it's at y equals 2. Y equals 2. The highest point is at y equals 2. And if you notice, that particular dot is shaded, so it can actually equal 2. So what it's basically saying is, guys, y is less than or equal to 2. And we created our range. So the range is y can be any value, right, that's equal to -4 or greater than -4, or any value that's less than 2 or actually 2. That's why we have less than or equal to and greater than or equal to or equal to. Okay? So once again, it's saying that y can actually be -4 or a value that's greater than -4 but less than 2 or actually 2. Okay? So this is the boundary. That's the vertical boundary, and this is the horizontal boundary, which is the domain. Okay? So once again, this is how we find out the domain, the horizontal boundary, and the range, which is the vertical boundary. Pretty simple, pretty easy. Okay? Guys, please tell your friends about my page. If you know any of your classmates or any other students or people that go to your school, right, that are struggling with range or domain or any concept that's about math, please tell them about my page, which is Danny Mathematics 3.0. Thank y'all so much for tuning in. Talk to y'all later.